Let's now consider the flow of fluid. This can get quite complex quite fast, but there are still many things we can consider at this level. One of the ways in which we'll simplify the discussion is to only consider ideal fluids which are incompressible and have no internal friction, which is otherwise known as viscosity. Internal friction within a fluid causes shear stresses when two layers flow against each other or at the boundary between the fluid and the containing wall. Flow lines describe the path that individual particles of the fluid take as they flow through space. And that's what I've drawn here. More realistic depiction is this. So these are flow lines around certain bodies. And so any particle coming along here would follow this path. If these flow lines aren't changing in time, then we call it steady flow. If they are changing, then we call it turbulent flow. And laminar flow is a mesmerizing phenomenon that occurs when adjacent layers of fluid slide smoothly past each other and the flow is completely steady. And it's really, I say mesmerizing because it makes the fluid look like glass. You really can't tell that there's movement in it at all. This picture it doesn't do it justice. Go ahead and look, if you haven't seen this already, on YouTube and do yourself the pleasure of seeing laminar flow. There's a lot of fountains that exist around the world with laminar flow, and you can just buy a fitting that causes it. But it's just really incredible. This still image may as well be a video because it wouldn't look any different. It just looks like a beam of glass, and then you interrupt it with your hand and it splashes all over. It's really incredible. Laminar flow.